Imagine racing a horse. Sounds ridiculous, right? A horse is stronger, faster, and built for running. So you'd lose in seconds, right? Actually, if the race lasts long enough, the horse might collapse first. Not because it's slower, but because it gets too hot. Humans have a secret weapon almost no other mammal possesses. We can cool ourselves while we're still moving. That strange, salty liquid dripping down your face may have changed the entire history of our species. Without sweat, humans might never have become the planet's dominant animal. Today, we're uncovering one of evolution's greatest engineering breakthroughs. And by the end of this video, you'll never complain about sweating the same way again. If you enjoy discovering the hidden story behind everyday human life, subscribe and let's travel back millions of years. Let's be honest, sweat is annoying. It ruins your shirt, burns your eyes, makes you smell, and somehow appears exactly when you're trying to look presentable. Most people think sweat is simply the body's air conditioner. And that's true, but only partly. Because humans don't just sweat a little. We sweat more than almost every other mammal on Earth. An average adult has somewhere between 2 and 4 million sweat glands. On a hot day, your body can produce well over a liter of sweat every hour. Elite endurance athletes can lose 2 or even 3 liters every single hour. That's almost like pouring an entire bottle of water onto yourself without ever picking one up. Which raises an obvious question. Why would evolution create an animal that constantly leaks water? Water is valuable, especially in ancient Africa. Every drop lost could mean the difference between life and death. So why did natural selection reward the species that wasted the most water? At first, that sounds completely backwards, until you realize evolution wasn't trying to save water. It was trying to solve a much bigger problem. Imagine standing beneath the African sun around 2 million years ago. No shade, no air conditioning, no cold drink waiting nearby, just endless open grassland and temperatures that could easily become dangerous. Now imagine trying to run. Every muscle inside your body generates heat. Your brain generates heat. Even thinking produces heat. The harder you move, the hotter you become. If your core temperature rises only a few degrees too high, your brain begins to fail. Proteins start breaking down. Organs stop functioning properly. Eventually, you die. Heat isn't just uncomfortable, it's one of the fastest ways for a large animal to fail. Almost every mammal faces the same problem. But most mammals solved it in a very different way from us. Dogs pant. Wolves pant. Lions pant. Even many primates rely heavily on breathing to dump excess heat. Panting works well, until you need to keep running for a very long time. That's because panting and running compete with each other. One is trying to breathe. The other is trying to move. Humans evolved something almost unbelievable. Instead of relying mainly on the mouth, we turn nearly our entire skin into a cooling system. Your skin is far more complicated than it looks. Hidden beneath the surface are millions of tiny structures called eccrine sweat glands. Each one acts like a microscopic pump. When your brain detects rising body temperature, it sends signals through your nervous system. Almost instantly, millions of glands begin pushing water toward the surface of your skin. But here's the clever part. Sweat itself doesn't cool you very much. Evaporation does. When liquid water turns into vapor, it steals heat away from your body. Every tiny droplet carries energy into the air. Multiply that by millions of droplets, and suddenly your entire body becomes a giant evaporative cooling system. It's surprisingly efficient. In fact, humans possess one of the most powerful cooling systems found in any large land mammal. But this incredible ability came with a price, a very big one. Imagine carrying 2 buckets everywhere you go. Now imagine both of them have tiny holes. That's basically what being human is like. Our incredible cooling system only works if we have enough water to lose. And unlike most mammals, we lose astonishing amounts of it. A zebra might stop running because its muscles become exhausted. A human often stops because dehydration begins stealing away performance. Lose only about 2% of your body weight in water, and your physical performance starts dropping. Lose much more. And confusion, dizziness, heat exhaustion, and eventually heat stroke can follow. So evolution traded one problem for another. Instead of overheating quickly, we became dependent on finding water regularly. At first glance, that sounds like a terrible deal. Why evolve a system that constantly risks dehydration? Because in the environments where early humans lived, staying cool for hours could be far more valuable than conserving every drop of water. Natural selection doesn't choose the perfect solution. It chooses the solution that survives long enough to have children. Sometimes that's good enough. But there was another problem. Even the world's greatest cooling system struggles. If it's trapped beneath a thick fur coat, imagine taking a shower while wearing a heavy winter jacket. The water is still there, but it can't evaporate efficiently. The same thing happens with sweat. Evaporation needs exposure to moving air. Millions of years ago, our ancestors probably looked much hairier than modern humans. So as sweating became more important, thick body hair gradually became less useful. Current scientific evidence suggests these two changes likely evolved together. More sweat, less fur. Not overnight, not in one generation. But across countless generations of natural selection, humans didn't become hairless. We became almost hairless. In fact, your body still has millions of hairs. They're simply so fine and short that most people barely notice them. Ironically, we're still furry mammals, just with a very unusual haircut. Now imagine the African savanna again. A frightened antelope sprints away. A zebra disappears into the distance. A horse-like animal would probably win a short race without even trying. Humans never had that kind of speed. Instead, we had patience. Scientists call this persistence hunting. Rather than catching prey in a burst of speed, early humans may have simply kept following it, hour after hour. Under the burning sun, the prey could sprint much faster. But every sprint produced enormous amounts of heat. Eventually, many large mammals needed to stop and recover. Humans kept walking, kept jogging, kept sweating, kept cooling. This strategy is still practiced by a small number of hunter-gatherer groups today, although anthropologists continue to study how common it was in the distant past. Whether persistence hunting was widespread or only used in specific situations remains debated. But it demonstrates something remarkable. Sometimes, the slowest hunter wins. Of course, sweat wasn't working by itself. Evolution assembled an entire team. Long legs reduced the energy needed for each stride. Large tendons stored and released energy like springs. Strong glute muscles stabilized the body. Arched feet acted like shock absorbers. A flexible waist helped balance each step. And our unusually large brains constantly adjusted posture and movement. Sweat was only one piece of a much larger machine. Remove any one of those pieces, and long-distance movement becomes far less effective. That's one reason scientists rarely talk about a single evolutionary breakthrough anymore. Human evolution wasn't one miracle. It was thousands of tiny improvements, stacked together over millions of years, like adding one brick at a time, until eventually, you've built an entire city. If sweating works so well, why didn't every animal evolve the same solution? Because evolution doesn't work like an engineer designing from scratch. It works with whatever already exists. Dogs evolved around panting. Cats evolved around panting. Lions evolved around panting. Most mammals solved overheating long before humans appeared. Changing to an entirely different cooling system would require countless, coordinated anatomical changes. That's incredibly difficult. Instead, each species keeps improving the strategy inherited from its ancestors. Humans happen to inherit a body that could gradually transform into something very different. The result wasn't universally better. A lion would never trade its explosive sprint for our endurance. A camel would never trade its water efficiency for our cooling system. Every species solves survival differently. There is no perfect body, only bodies adapted to different problems. The next time you complain about sweating, remember what your body is actually doing. Millions of microscopic glands are working together. Tiny droplets are carrying heat away from your skin. Your brain is constantly measuring temperature. Your blood vessels are adjusting. Your heart is changing its rhythm, all without you noticing. It's one of the most sophisticated cooling systems evolution has ever produced. And it operates automatically, every single day. The strange thing is, most of us only notice it when it becomes inconvenient. Yet without it, walking across a hot parking lot could become dangerous. Running a marathon would be nearly impossible. And humanity's journey across the world's hottest landscapes might never have happened at all. Sweat may seem unpleasant, sticky, smelly, annoying, but evolution rarely cares about comfort. It cares about survival. Somewhere millions of years ago, our ancestors began turning their skin into one of nature's greatest cooling systems. That single change helped make long journeys possible. It helped humans survive where many animals struggled. And together with countless other tiny evolutionary improvements, it helped shape the species you are today. So the next time you wipe sweat from your forehead, remember, you're watching millions of years of evolution doing exactly what it was designed to do. If you enjoyed uncovering another hidden chapter in the story of humanity, let us know what evolutionary mystery you'd like to explore next. And if you're curious about the science behind what makes us human, subscribe, because we're just getting started.